Good day, future LPTs. So this is a new episode of Marshall the Teacher Reviews. So in this review video, we will be discussing about kinds of fluids. So this is one of the topics in physics, specifically in fluid mechanics. Before we identify the kinds of fluids, we must first define what is fluid. So a fluid is a liquid, gas, or other material that flows or continuously deforms under a shear force. So ang fluid, guys, is any liquid or gas, diba? Or any material that cannot sustain tangential or shearing force. So, kapag may external force na nag-exert upon this material and nag-change yung shape ng material na yon because of that external force, and that material is fluid. What are the different types of fluids? We have ideal fluid, real fluid, Newtonian fluid, non-Newtonian fluid, ideal plastic fluid, thiotropic fluid, incompressible fluid, and compressible fluid. So, di-discuss natin to isa-isa. So, what is an ideal fluid? From the term ideal, diba? It is an imaginary fluid. Ginagamit lang to for examples, diba? For as a standard, though hindi to masasabi in reality. So, ideal fluid, it is one which has no viscosity, no surface tension, and incompressible. In nature, no fluid having such properties. Thus, it is an imaginary fluid. But there are few liquids which can be considered as ideal for all practical purposes, like water, which has low viscosity, low surface tension, and great resistance to compression. So, there is no ideal fluid talaga, pero merong fluid na nalalapit yung properties doon sa ideal fluid, and that is water. Kaya mostly in fluid mechanics, water ang example. Next, we have the real fluid. A fluid which possesses properties such as viscosity, surface tension, and compressibility, also known as fractal fluid. All fluid available in nature is real fluid. So, lahat ng fluid na nakikita natin in the nature, that is real. Kaya siya tinawag na real fluid kasi it exists in reality. It exists in the nature. And yun yung water, yung air, yung helium, yung mga elements na nakikita nyo dyan, na liquid in a liquid and gas form. Yan, mga fluids yan. Yung nakikita nyo, nararamdaman, natatouch nyo, these are real fluids. Next is Newtonian fluid. When the fluid obeys Newton's law of viscosity, shear stress is directly proportional to velocity gradient. So, Newtonian fluid, guys, ito yung mga fluids na nakikita natin sa nature that Newtonian physics could be applied. So, ang Newtonian physics na yon, it specifies the Newton's law of motions, diba? So, the gravity, yan. So, kapag ang fluid ay na-apply ang Newton physics doon, and that is a Newtonian fluid. And the specific physics law na may apply doon should be the law of viscosity. Non-Newtonian fluid. These are a kind of fluid that doesn't obey Newton's law of viscosity. For example, blood, grease, and sugar solutions. So, itong fluid na to guys, hindi natin may apply ang Newtonian physics here. So, there's no shear stress and low to no viscosity. So, the physics laws, the classical physics laws, could not be applied here. Kaya kung mapapansin nyo yung behavior netong non-Newtonian fluid is kaiba sa water or sa gas, diba? Sa glycerin, yun, ibang-iba. So, let's see the difference between the two, the Newtonian and non-Newtonian fluids. So, first difference, in the Newtonian fluid, it obeys the law of viscosity. And in the non-Newtonian fluid, it doesn't obey the Newton's law of viscosity. So, later on, madidiscuss natin what is viscosity. Pero, viscosity guys, in general, it is the rate of flow of fluid. Yan, that is viscosity. So, next difference is their equation. So, dito kasi sa Newtonian fluid, so let's first analyze the equation. Tau is equals to mu multiplied to dV over dy, or shear stress is equals to coefficient of dynamic viscosity multiplied to rate of shear strain. Okay. Meanwhile, in the non-Newtonian fluid, the shear stress is not equal to the product of coefficient of dynamic viscosity multiplied to velocity gradient or rate of shear. So, in their formula, tau is equals to infinite dV over dy. So, it means that the shear stress is directly proportional to the rate of shear strain. That is in the Newtonian fluid. Meanwhile, in the non-Newtonian, it means that shear stress is inversely proportional to the rate of shear strain. Yan yung pangatlong difference nila sa isa't isa. Next difference is that apparent viscosity is in the Newtonian fluid, that apparent viscosity is constant. So, meaning that apparent viscosity is equal to the Newtonian viscosity of the fluid. But in the non-Newtonian, apparent viscosity depends on the shear rate. So, last difference is that linear relationship between shear stress and rate of deformation. There is a linear relationship between the shear stress and rate of deformation. Meanwhile, in the non-Newtonian fluid, there is a non-linear relationship between the shear stress and rate of deformation. So, if you could see the examples that we have in the Newtonian fluids, we have glycerin, kerosene, and water. Now, kung i-compare natin siya sa non-Newtonian fluids, toothpaste, gel, and slurries, in our observation pa lang, diba, ang laki na ng difference between the two fluids. So, this is the representations of Newtonian and non-Newtonian fluids in a graph. So, the blue line represents the Newtonian fluid. Meanwhile, the curved lines represents the non-Newtonian fluids. So, bakit nga ba straight and curved tong mga fluids na to? So, Kaya straight ang Newtonian fluid because there is a linear relationship between the shear stress and the rate of deformation. Meanwhile, dito naman sa curve na to, it represents that there is no linear relationship between the shear stress and rate of deformation. Kaya ganyan yung itsura nila. Ideal plastic fluid. So when the shear stress is proportional to the velocity gradient and the shear stress is more than the yield value, meaning after reaching a value of shear stress, the fluid begins to flow. The flow of fluid such that the relation with the shear stress and velocity gradient is linear is also known as Bingham plastics. So, ang examples ng ideal plastic fluids natin, we have the toothpastes. Yan, ideal plastic fluids. Yan. So, yung mga kagaya ng toothpaste, yun, mga ideal plastic fluids. So, next is compressible fluid. A compressible fluid is one in which the fluid density changes when it is subjected to high pressure gradients. For gases, changes in density are accompanied by changes in temperature, and this complicates considerably the analysis of compressible flow. So, if the fluid, diba, change density because of the high pressure or the external forces, then that fluid can be considered as compressible fluid. So, most of the fluids naman are compressible. Yung iba nga lang medyo mahina at yung iba medyo malakas. Incompressible fluid. So, when the density of the fluid doesn't change with the application of external force, it is known as incompressible fluid. So, kanina, na-discuss natin that most of the fluid are compressible. But most of the fluids as well are incompressible if that fluid flows. Diba? Kapag nag-flow yung fluid, then it could be highly considered as incompressible. So, pero there is no real incompressible fluids. But, nangyayari lang or nagkakaroon lang na incompressible fluids kapag may fluid flow na tinatawag. So, for many flow circumstances or flow situations, the changes of density due to the changes in the pressure associated with that is very small. Okay. So, yun. It greatly simplifies that the solution of fluid flow equations to treat the fluid as incompressible. Okay, basta nag-flow ang fluid, then it is highly incompressible. So, yon ang discussion about kinds of fluids. Mas pinadaling version than the technical terms. So, I hope that you have understand it even though hindi siya napaka-technical kagaya ng sa books. Please like and subscribe my YouTube channel for more videos.